time has come, the ghost has said, to speak of Pac-Man things, with dots and fruit and power pills and insights source code brings. Apologies to Lewis Carroll. Let me tell you about how I built NABU Pac-Man way back at the start of the 80s. I hope you find it fun and educational. When I started at NABU, I created the framework for what would become Pac-Man in September 1982, when I was still training as a programmer and not yet tasked with delivering anything. It wasn't animated yet, just shapes, a circle for Pac-Man and a rounded door shape for the ghosts as sprites. I had to drop working on Pac-Man in October 1982 because I started working on Roulette with Ken Shimizu. I worked behind him on another NABU 1100 workstation. They had 8-inch floppy drives and ran a modified version of CP/M 2.2 called MCP 1.8. Development started on Pac-Man, but it was put on hold while I worked on Roulette. You see, I was working part-time at NABU back then, so I didn't have a ton of time to work with. I was also going to school. But during the Christmas holidays, I worked on it a bit more, and by January, it was all I was working on, but still part-time. Some of the design choices I made for the home conversion of Pac-Man shaped the implementation. I wanted to make the best-looking version of Pac-Man at the time. In fact, several console and computer versions of it existed already, but I had to make mine better than any of those because I felt it hadn't been accomplished yet at a microcomputer level. If you notice, our opening screen even mimics the track mode in the actual arcade machine. Everyone who knew the game was instantly familiar with it. First impressions were everything to me. I was already a 100K plus scoring Pac-Man player, so I already had an innate feeling about the ghost patterns, but I also bought a book by Ken Houston called Mastering Pac-Man. Yep, that book right there, Mastering Pac-Man. I still have it somewhere in a box somewhere. I'm pretty certain I can find it if I really, really looked. But in this case, I don't have it anymore. We hadn't yet started to videotape arcade games like we did with Qbert. Thus, checking of the play would involve me going to a local arcade to play a bit more every few days. Now, the source code, we received no source code from Namco. It wouldn't have helped us much anyway, because Pac-Man, the arcade game, is a custom arrangement of chips that NABU did not mimic in any way. So without keeping you in too much suspense, you can find the source code to NABU right here. It's at https://github.com/leobinkowski/nabu/nabu-pacman, the first link in the thread. The other links are going to become important in a second, so we'll get to them. But if you want to download the code, you can follow along if you like. Now, the arcade machine TV display had a different orientation than television sets prior to 2000. They use a horizontal 4:3 orientation instead of the TVs do, instead of the arcade games, which use a portrait mode kind of 3:4 orientation, which forces choices to be made. I wanted to use the entire screen as much as possible, and Atari had already taken liberties with the Pac-Man arrangement, so I squashed the board a little bit, but really only by about 4 horizontal rows of dots, and I moved the score into the ghost home. The fruit would appear along the right side vertically instead of on the bottom as on the arcade machine. The great thing about this setup was that I could rearrange the maze at will. The walls and dots were like Lego bricks and patterns. I had my eye on Ms. Pac-Man as well, so this code would be reused. Now, when we're talking about timing for the game, there are no timing loops in Pac-Man. All action is derived from the clock tick of the vertical blanking interval produced by the TMS 9918 graphic processor. The tasks attached to this clock were the keyboard input task, so whenever I read the keyboard, the ghost body wiggling task, whenever the ghosts were going, the background woo-woo noise, the Pac-Man movement and joystick input routine, the power pills flashing, the fruit appearing twice aboard. Each ghost itself had its own task, so there's 4 of those. And when music is played, that has its own task. And there's a reversal task that shows up twice around, which causes the ghost to literally reverse the direction that they're going in. And it happens at a specific time, so you can actually see when that happens. I extended those macros with my own controller in supertask.mro, when this allows me to adjust the speed on the fly so I can slow down tasks. For instance, when Pac-Man eats dots, he moves slower than he does when he's not eating. Also in Pac-Man, ghosts lose a little bit of time by turning a corner. I account for this by slowing them down around curves as well. In general, the tasks are also capable of interfering with each other. There's race conditions. If you need to keep them separated by data or stack in order to cause them to be reentrant. So you have to be worried about those kinds of tasks. One of the things that differentiates my Pac-Man from MSX Pac-Man was that I was able to add whites of the eyes to the ghost. This is how I achieved it. You can see as I move around there, all the ghosts have eyes and all of the ghosts have bodies. So let's just stop this for a sec. and show you what's going on. Though the TMS9918 video display processor in the NABU PC is capable of displaying 32 different sprites at the same time, it has a very annoying limitation that it can only display 4 of those in the same horizontal line. This meant that in order to make sure that the ghosts would work, that I can't have all the ghosts on the same line in PAC-MAN at the exact same time, but they could only be one color as well. So what I really wanted was the whites of the eyes, so I actually had a formal design meeting with John Short and Arthur Ham. Arthur suggested I animate the eyes themselves using the pattern table of Graphic Mode 1, which I was already using for the borders and the dots. I carefully drew the eyes so that they would stay in an 8-bit plane and animated by shifting them 2 pixels as they moved. I also had 4 sets of eye patterns for each direction. I kept track in memory of what was supposed to be underneath those eyes, like dots or spaces or power pills or anything, so I could replace them when I moved away. Since each ghost ran on its own task, all kinds of race conditions were showed up that took me a few weeks to completely eliminate. Eye droppings, or what I call turds, were left all over the screen as a result of some of those bugs. Now, the original NABU PAC-MAN development machine was one of these NABU 1100s, as I mentioned earlier. This bar fridge-shaped computer was made of wood. Actually, the whole case is made of wood, and it was the predecessor to the NABU PC. If you look at this panel, it actually has a little set of joysticks on it, and that card was the HTCC card, which was an S100 card, which plugged into that machine, and used the Z80 in that machine. However, the Z80 in that particular machine was running at 4 megahertz because it didn't have a TMS9918 originally to do its timing. So the HTC card actually ran at a slightly different clock speed, and this causes us some problems when we were doing the video games. The very last version of PAC-MAN that I wrote was also compiled and assembled on the NABU 1100, and I actually moved it over to the NPC development machine afterwards, mostly to use snippets of code whenever I wanted to. All that to say that the source code I recovered wasn't directly buildable on the NABU PC for a number of reasons. Because we were using 2 floppies, the include files for files common to Z80 assembler-based projects as well as other languages are referred to on the A drive and were not included with the source. The development tools were not included with the source, which I'm describing here: M80, L80, lib, and plink. Plink is Phoenix Link. The other build and cycle instructions were actual paperwork was not included because it was paperwork. So that has information about how it was built. And was literally submitted on paper with the floppy diskettes. And I don't think anyone else ever built anything that we submitted to source code control. I think they never were looked at again. And that would have been the absolute truth because they would have come back to us to make any changes. So in order to build the stuff the way that I'm used to, we require CP/M. In my case, I was using CP/M3, the NABU version, but it was on a hard drive, so I had lots of space. But at the bare minimum, you're going to need a machine with submit.com, M80.com, which is the Microsoft macro assembler, L80.com, which is the Link80 linker, lib.com, which is part of that whole package, which packages separate rel files into a library for use as one big rel file, and cab build to turn it into a NABU application to add the checksums to the COM file, and plink2.com. I used plink1, which is a little bit different, but I did find plink2, and it's essentially the same software. And this is because L80 is not capable of doing programs bigger than 32K roughly on a machine. I'm not exactly sure why it has that weird limitation. It doesn't matter how much memory you give it. It's not good at doing stuff greater than 32K. So plink was one that could manage that. The 37K version of PAC-MAN at the time. But I've set up all the code so that I've rearranged it. There was a do-all.sub, which is a submit file, which basically compiles everything, packages everything, compiles everything. The only thing it doesn't do is the cab build part. For a number of different reasons, we never included that in the file. but in this particular case, the do all that sub contains all the things that I have to get. Now, there's one bit of source code that I couldn't find. I could only find a rel file for it, which is na2logo.rel, and it's not. I don't think it's the right one that goes with this, and you'll see why. Okay, let's take a look at code then. This is my Visual Studio Code, and this is the main entry point. This is PAC-MAN.mac, or this is the main file that we start with. And what's interesting about this is you'll notice that most of the files have these big headers at the top, and we actually have a part number. The part number for PAC-MAN being 90034420, and that stayed with me forever. Now, we didn't have source code control that would automatically add comments and that kind of stuff, so we put comments in our code. And this is Rev 4 of PAC-MAN, which is, and I built this on the NABU 1100, but because it was built in June 1984, which is around the time I had to make one change to make it match the standards. That's pretty much it. But as you move through here, the main entry point is there's some include files that you will see here that are going to be added, and we're going to talk about those in a bit. There's some data sets that I set up, and what I really wanted to talk about regarding that was we have to make, what we have here is plink requires .main dot as the main entry point, whereas L80 we can specify it with PAC-MAN. So I left both of them in there just in case we wanted to do both. Now, there's also, you will see that the first thing I do is when I start is we set the stack pointer. Now, location 6 tells us where the bottom of the operating system is, so we load the stack pointer to be right under the operating system to maximize the amount of stack space we have. Our program will start loading at 100, and it will go up to wherever, so that makes sure we have the maximum amount of stack space that we can use. Now, the next thing that we do, which is kind of interesting, is you'll see us do something called link.io link tab. Now, what this does is this connects the API of NABU to the link table, which can be changed inside, but in practice, we never actually changed the size. We just linked it to the entire table. Other people never bothered because we passed the files around, so making a changed version with less of the API in it would likely cause grief to somebody else. Now, the link tab was only intended to be used specifically by applications that needed to use the operating system. It wasn't for CPM applications whatsoever. Now, the other thing that we had the tendency to use is we had macros, lots of macros, and some of them are just convenient ones, but other ones were structured macros so that we could create structured code. We could create for loops, which using an 8-bit value. These are assign statements, which are essentially like let statements, and block macros. We had ifs, whiles, untils, repeats, and if then else. It was actually quite useful to have those in assembler. So that's how we had that set up. So here's an example in the code where I'm using if statements and while statements into the same area. And I also had a macro called pcall, which means parameter call. And what it would do is that the first parameter is the routine you're calling, and each successive parameter was put values into B, C, D, E, and HL of the Z80 as you needed them. So that was our convention, using B, C, D, E, and HL as the first, second, and third parameters of any routine that we were calling. Now, I mentioned multitasking earlier, and I mentioned all the different tasks we were doing. Here's a bit more detail on that. The NABU iOS had a very simple timing mechanism that was tied to the VBI. Every 60th of a second, when the scan line of the TV was just about to move to the top, an interrupt was sent to the Z80. This was important because at the very moment, it was possible to write around 768 bytes to VRAM before it would cause problems on the screen, like artifacts or weird snowy effects. We called those tasks, and the task was defined in a task controller block, or TCB. In the clock@.mro file, there's a macro called sets, which sets up task given its address, TCB, task interval, and start time. I also extended the task system in order to make it useful for PAC-MAN with a macro called speed, which allowed me to modify the speed of the TCB and its execution time, when it was going to execute next on the fly, so I can make some minor adjustments. And this will let me make minor adjustments to the speed of the Pac-Man and the ghosts as they went about their business. So when Pac-Man was eating dots, he went slower a little bit, and when ghosts were turning corners, they went slower a little bit. In other words, you can outrace ghosts by going through lots of curves. Now you'll notice when there's a lot of tasks being done, like here on the screen here, I do this other thing called CR bag, and at the end of it, I call CR end. And what CR bag means is critical region begin and critical region end for CR end. And what that means is during that portion of time, all interrupts, except for the non-maskable interrupt, which is the reset switch, are ignored. They're basically completely turned off. Now, the ghost logic is in 4 different files. It's in ghostmv.mac. That's where Blinky is, and that's where the main ghost routines, the common routines that everybody else is using as well. And I actually have an inkmove.mac, which has specific routines for Inky, a clymove.mac for routines for Clyde, and I have a Pinky one as well, pinmove.mac, where we should be down here. Where we got it. Pinmove for Pinky's movement routines. As you notice, there's really not much to each of the different ghost routines. They do have some very specific things. Pinky moves a little bit faster on the straightaways, and Inky, when if you're heading towards him, he will try to take an exit. And Clyde he's literally the slowest of everybody. He's also the most deferent of everybody, and he will take any exit that anybody's not doing to not get necessarily closer, but to try to circle Pac-Man. It's kind of a weird algorithm for him. So besides the opening animations that mimics the track mode of the arcade Pac-Man, there were also 3 interlude animations that would play after the 2nd, 5th, and 9th boards. Laura Schenning and I worked on the framework for the first interlude, but then I just sent her off because, and she ended up completing all 3 interludes. The music was done from a friend of mine from high school named Tom, but I can't remember his last name at the time, but I called him in because he was in the stage band at Glebe, and I knew that he had an incredible musical ear and he could recreate all the notes for us. Now, a side note about Laura Schenning, she joined NABU from the same computer camp where we were counselors. She was a year younger than me, but was in the computer camp, the computer science program at Glebe, where we both went. She was also stunningly pretty and was also spiffily dressed all the time. I considered her a colleague and super quick with a joke. She was wonderful, and I knew her older brother. She was in a grade below me, but her older brother, Rob, was in the same grade as I. Pac-Man is the only game I worked on with her, but she also worked on runes and some of the educational software as well. And she had one of the best Halloween parties we ever had that included a lot of NABU employees. Now, graphic data is also included with this, and there's not a lot of description. And the reason why are these are actually produced by another program called Gred.com, which is graphic editor, and it made sprites and patterns for us. So I'm looking for a copy of that to see if I don't have one. So far, I haven't been able to find one. But it reads these files and also writes these files. And these are actually, the first number is the amount of definitions in this file, and of that definition, the first number of each row tells what pattern it is, and the rest of it shows the pattern definition. That's as much as I know about it, and I'm pretty certain other people figured it out. So on to building the game. I originally had a dowall.sub that assembled and linked everything into pacman.com. I found it was actually incomplete, though, because I was using rel object files instead of stores in most of them, and I couldn't find all the source in one spot. I've tried to find all the source I can, but there's still one that I'm missing. na2logo.rel is the rel file that I have, but I don't know where na2logo.mac is, and that causes me grief on this particular build. And I will show you how that works. And now I'm going to talk a little bit about the tar pit that I'm in. So I've been trying to build NABU Pac-Man in a number of different ways. And the first thing I tried was to use a 720K floppies 720K floppy images, but it's not quite enough room to compile when I was done, which was a real pain in the butt. So I ended up changing things a little bit, and I started using Cloud CPM. And Cloud CPM has a wonderful feature where I can move stuff into my D drive and just make one and move all the stuff and do it. However, Cloud CPM seems to have a problem running submits, so I have to actually type every last line inside of the doall.sub to make it compile. Now, the main problem is I compiled all of this and put it all together, and what I ended up with, so as I more or less, let's just move this a little bit farther, and shows me doing the lib, but as I ended up building this, and I ended up linking it with plink as well, which is right here, and I ended up making a PAC-MAN.com, and that's wonderful, except that when I actually copied this over and I ran it, we started to have problems. As you can see, the NABU logo was wrecked up there, and I don't know what that is. But moreover, when I started running it, it just hung after it did the initial opening animation, which I could show you here. It just kept going, and then it stopped and hung. So I am going to let everybody else have it. The NABU development system is in such a big flux that other people are going to figure out how to do this better than I. I will eventually figure out how to get my development system working with hard drives and that kind of stuff, and working on CPM3 and submit working on NABUs. Until that happens, I'm not too worried about it. I can submit the code and everybody else can be happy with it. So I encourage you to download the source, try to figure it out yourself, see if you can make it work, change the mazes, make a new game if you can. And finally, before I go, may the source be with you.